Acceleration due to gravity remains constant, but the object now is in the position of B. Therefore, we cannot write h as the height. Just look at the figure. Now the object is here and the height from the ground is h minus x. Therefore, we have to use h minus x. Then opening we get mgh minus mgx. This is the potential energy. Then for total energy, we have to add kinetic energy plus potential energy. That is, total energy is equal to kinetic energy is mgx plus potential energy is mgh minus mgx. Look here, there's a positive term mgx and corresponding negative term mgs. This positive mgx and negative mgx cancels each other and the total energy remains constant as mgh. In A, we get the same as total energy, that is mgh. In the point B also, we are having total energy as mgh. So we have to find the same for point C also. If it is same mgh, then we can say that the total energy of a freely falling body remains constant. Then law of conservation of energy is applicable for freely falling body. Then we are finding the total energy at C. Kinetic energy is equal to half mv square. Mass remains constant. We have to find the value of velocity by third equation of motion, not Newton's third equation, not Newton's third law of motion. It is third equation of motion, that is v square is equal to u square plus 2as. Since the object is dropping from a height, that is, it is executing free fall, the initial velocity is 0. Therefore, the term u square gets cancelled as 0. Then v square is equal to 2 into, like the same way we write this at point B. The object is executing free fall. The acceleration acting on an object executing free fall is acceleration due to gravity. Therefore, we can write g in place of a into s is the displacement. From A to C, the object is moving through a displacement h, that is the height of the point A. From A to C, the object is moving through a displacement h. Look at this figure from A to C. What is the displacement? H is the displacement. Now we got the value of v square as 2gh. Then kinetic energy is equal to half into m into 2gh. 2 and 2 got cancels each other, then it becomes mgh. Now we need potential energy. Potential energy, the equation for potential energy is mgh. But look here, C is the point on the ground. C is the point on the ground. Therefore, h is equal to 0. H is the height from the ground level. H is the height from the ground level. Since the point is on the ground itself, h is equal to 0. Then potential energy is equal to mg into 0. It becomes 0. Now we can write total energy as kinetic energy plus potential energy. Kinetic energy is mgh plus potential energy is 0. That is mgh. Now we derive three conditions at A, B and C. At A, at B and at C, total energy is the same mgh. That means at A, B and C, total energy remains constant as mgh. Therefore, we can say that energy is conserved in the case of freely falling body. For a freely falling body, total energy remains constant. Therefore, law of conservation of energy is applicable for freely falling body. That's all about our second topic, energy. Now we completed two sections of this chapter. First one is work and the second one is energy. And we are moving to the final section, that is the third section of this chapter, power. It's a simple topic. Now we completed the second section and moving to the third section, power. After all, it is very simple topic. Power is defined as the rate of doing work. Power is defined as the rate of doing work. Power is defined as the rate of doing work. Then we can write power as power is equal to work divided by time. Power is equal to work divided by time. That is P is equal to W by T. This is the equation for power. P is equal to W by T. P is equal to W by T. From the equation, we can find the unit as unit of power is equal to, look here, in the denominator we are having work and unit of work is joule by unit of time is second. Then the unit of power can be written as joule per second. Unit of power can be written as joule per second. But in SI system, system A international unit of power is watt. It is watt, represented by the letter W. The SI unit of power is watt. It is represented by the letter W. This is called power. It is the rate of doing work. Power is equal to work by time. Unit is watt. We are having larger units for power. We are having larger units for power, that is kilowatt. Then 1 kilowatt. 1 kilowatt is equal to 1000 watts. This is a larger unit of power, that is kilowatt. 1 kilowatt is equal to 1000 watts. Moving to the commercial unit of energy, that is the reading we got from our electricity meter is the commercial unit of energy, that is the electrical energy. That's what the commercial unit, and the commercial unit is kilowatt hour, and the commercial unit is kilowatt hour. Then 1 kilowatt hour is equal to 1000 watts into seconds. 1 kilowatt hour. 1 kilowatt is 1000 watts and 1 hour is 60 minutes into 60 seconds. That is 3600 seconds. This is 1 kilowatt hour. And multiplying we get 36. This is it. 1 kilowatt hour is 1000 watts into 3600 seconds. This is the larger unit and commercial unit of power. This is the larger unit and commercial unit of power. Remember, whenever you are asking about the commercial unit, it is the kilowatt hour. It is the kilowatt hour. What kilowatt hour means? Kilowatt means 1000 watts and 1 hour is the 60 minutes into 60 seconds, that is 3600 seconds. Like the same way we are calculating the electricity bill from the meter placed in our home. That's the commercial unit of power. That's all about power. We finished the third section also. That means this is the last topic of the chapter, and we finished the chapter number 5, work, energy and power. Now let us recollect what we have studied in this chapter. In the first topic, that is work, we defined what work is, then classified work as positive work, negative work and zero work. In the second section, energy, we just explained the term energy and forms of energy. Among these, most prominent ones are kinetic energy, potential energy, and then law of conservation of energy. Law of conservation of energy. In power, we explained what the term power defines or what it indicates, and commercial unit of power and commercial unit of power. That's all about this chapter. That's what we have discussed in this chapter. Just study well and remember what all we have studied in this chapter. I am Nitishas and thank you for joining me in this section. Let us meet another section in another day. That's all. Thank you.